Hello everyone and welcome to the finals revision. First chapter, which is going to be on finals, is chapter 21 about ratio and proportion. So I've prepared some questions from this chapter, and what I'm gonna do is I'm gonna solve these questions and I will explain to you how to solve them. Okay, first question. A map is drawn to a scale of 1 to 1 million. A forest on the map has an area of 4.6 centimeters squared. Calculate the actual area of the forest in square kilometers. Okay, so again, a map has a scale of 1 to 1000, or 1 million, sorry. 1 million. Forest on the map has area of 4.6 centimeters squared. This is on the map, and in life it's going to be equal to something. We don't know what is this something. We don't know, but actually we can find it by doing. So if it's 1 to 1000, it means 1 to 1 million, sorry. It means that 4.6 centimeters squared would have to be multiplied by a million. So 4.6 times 1 million would be equal to 4,600,000 centimeters squared. But then again, calculate area in square kilometers. So they ask us to answer in kilometers squared, and we have to figure out. So we know that 1 kilometer equals to how many centimeters? Actually, we can say in meters equals to 1,000 meters, and 1,000 meters. So 1 meter has 100 centimeters. So 1 kilometer is going to be like 100 times 1,000 equals to 100,000 centimeters. But this is 1 kilometer. 1 kilometer squared equals to 100,000 squared centimeters squared, right? Equals to what? What is it? 100,000 squared. It's gonna be like 1 with 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah? What number is it? 10. Oh my god, it's like 10 billion. 10 billion centimeters squared. So 1 kilometer squared equals to 10 billion centimeters squared, right? Then 4,600,000 centimeters squared equals to 4,600,000 divided by 10 billion. Oh my goodness, such a big number. 10 billion would be equal to, I'm gonna take a calculator for this, I think. You don't actually need a calculator, but I'm just too lazy to do that. So 4,600,000 divided by 10 billion. .00046. It's actually kind of a complicated question, I would say. 0.00046 kilometers squared, like this. Okay, next one is about proportion. This question is about proportion. Y is directly proportional to the square of x minus 1. So again, we have to read carefully. Square of x minus 1, that's equal to x minus 1 squared, like this. Yeah? X minus 1 squared. So y equals 63 when x equals to 4. Find the value of y when x equals 6. So y is directly proportional. So we write like this, we have this sign. It's directly proportional to x minus 1 squared, which means that y equals to k times x minus 1 squared. Right? And we know y equals 63. Y equals 63 when x equals to 4. So what does it mean for us? It means that we can take these values. We can take 63 we can replace y with 63. We can take 4, we can replace x with 4, right? So we will have 63 equals to k times 4 minus 1 squared, like this. Yeah? So that would mean let me write it here, yeah? Or actually, let's just write it like this, yeah? So 63 would be equal to k times 3 squared, right? It means that 63 equals to k times 9. It means that k equals 63 over 9 equals to 7, right? K equals to 7. It means that we can write a general equation as, so we can take k here, and then we can write general equation like this: y equals 7 x minus 1 squared. And now we have to find the value of y when x equals 6. So we can say like y equals what? Y equals to what when x equals 6? How to do this? So here we have to, well, we can actually just say y equals to 7 times 6 minus 1 squared, which would give us 7 times 5 squared, which is 7 times 25, which is equal to 175. So y is equal to 175. This is an answer to this question. Next, what do we have next? Next we have a car passes through a checkpoint. Okay, this is about speed time graph. We have to read this very carefully, okay, because we have to draw the graph here. A car passes through a checkpoint at time 0 seconds, traveling at 8 meters per second. It travels at this speed for 10 seconds. So when we start at 0, we are already traveling at speed 8 meters per second, and we do that for 8 seconds, okay? So 8 meters per second for 10 seconds, sorry, like this, yeah? It travels at this speed for 10 seconds. The car then decelerates at a constant rate until it stops when t equals 55 seconds. So we have to decelerate, and then we have to come here to this point, yeah? Because car stops at t equals 55 seconds. So let's draw this graph. Yeah, this is our, okay, let me try again. It has to be a straight line here. Yeah, it has to be a straight line. So first we travel at 8 meters per second for 10 seconds, and then we decelerate, so it means the speed is decreasing. Decelerate is decreasing, right? It's decreasing until we stop at 55 seconds. Okay, so this is our speed time graph, and now we have to calculate the total distance traveled by car after passing through the checkpoint. So again, distance for speed time graph, distance equals to area under graph. Distance equals to area under graph. We can find area under this graph pretty easily, right? We can divide this into a rectangle and triangle. So for this rectangle, area for this rectangle would be equal to, so it's like here the length of this rectangle is 10, right? So it's equal to 10 times, and the width of this rectangle is 8. I know this is a little bit deceiving because this actually looks longer, but don't forget we use different scale, we use different units. So this is, again, let me write this for you. So let me use some different color for that. So this here, this is 10, and this is 8, right? Then area is equal to, I'm gonna use green as well. So area equals to 8 times 10 equals to 80 equals to 80 centimeters. Oh, not centimeters, just 80 units in this case. Actually, it's going to be meters because we use meters in here, yeah? So the distance is going to be in meters, right? This is important. And here, for this triangle, is going to be, so we can find, we already know the height, and now we can find the base. So the base is going to be, we start at 10, we finish at 55. So the base in total is going to be 55 minus 10 is going to be 45. This is the length of base. Yeah, then area of this triangle is equal to 1/2 times height times base, right, which is would be equal to 180. So distance would be equal to 80. Again, take a look at this, please. So here the area is 80 for this rectangle, and for this triangle the area is 180. Yeah, so distance would be equal to 80 plus 80 would be plus 180, sorry. 80 plus 180 would be equal to 260 meters. Okay, that's it for this question. Again, look carefully at the picture. And we have to go to next question. This one, so here we have diagram. The diagram shows the speed time graph of the train journey between two stations. The train accelerates for 3 minutes, travels at a constant maximum speed of 40 kilometers per hour, then takes 4 minutes to slow to a stop. Calculate the distance in kilometers between the two stations. So again, distance equals to area under graph. And this time, you know what, I don't want to divide it into shapes, because this is actually a trapezoid, right? This is a trapezoid. And here, this side is equal to, it's going to be like 3 minus 22, because this is 3, and this is here, this is 22, right? So the total size of this side is 19. And here, as for the base, the size of a base is 26, right? And the height is 40, right? And don't forget we use kilometers, so the distance is going to be in kilometers. So, but actually, wait. This is minutes. So here we use minutes. Again, it's a bit misleading because they don't tell us, but this is minutes. This here is minutes. So we have to convert them to actually hours. We have to convert them to hours. These minutes, we have to convert them to hours to be able to find it properly, because we can't keep them as minutes, because kilometers per hour, 26 minutes and 19 minutes, so 19 minutes would be equal to 19/60 hours, and 26 minutes would be equal to 26/60 hours, like this. So distance in this case equals area under the graph. And we know that formula for area of trapezoid is like this: a plus b, where a and b are two bases, times h divided by 2, like this. So in this case, it's equal to a plus b. So we go 19/60. Sorry. Okay, let me write it bigger like this: 19/60 plus 26/60, yeah, times 40 divided by 2, yeah, 19/60 plus 26/60, sorry, that's a mistake, it should be 60, so it's going to be 45/60 times 40 divided by 2, that's equal to 45/60 is like 3/4, times 40 divided by 2. This is, we can cancel this, we can cut this, right? Cut, get 10 and 1. So it's like 3 times 10/2, which is equal to 15 kilometers. 15 kilometers is the answer to this question. Again, please look carefully at this question and at this one. Speed time graphs. Okay, one more topic is equations, formula, and functions. And first thing we have to do is we have to rearrange the formula to make x the subject. Yeah, y equals x squared plus 4. As you can see, all the questions are actually from past papers. Yeah, and also in the exam, all questions are also going to be from past papers. Just so you know, ladies and gentlemen. Y equals x squared plus 4. Let's rearrange it. So first we take 4 to other side. We get y minus 4 equals to x squared. And then we have to get rid of square. So we know how to do this. We have to take a square root from both sides. Like this. Yeah, so x is equal to square root from y minus 4, and that's it. That's the answer to this question. Make pi the subject of formula. Okay, this one is, make y the subject of formula. I thought they say pi. A equals pi x squared minus pi y squared, yeah? Let's take this one here. So a minus pi x squared equals to minus pi y squared. Now you know what we can do? We can divide both sides by minus pi, yeah? So a minus pi x squared over minus pi equals to y squared, yeah? Okay, what we can do now is we can transform this into pi x squared minus a over pi, because I don't want to have this minus on bottom, it doesn't look good, equals y squared. So if you change those two, if you change them, you can kind of cut this minus out. And that's how it works. And now all that's left is to take a square root from both sides. So y is equal to square root pi x squared minus a divided by pi. Okay, that's it for this question. Again, look carefully at this material. Next one, here we have, I think I didn't make a good cut. I think I have to, wait, I had this somewhere. I think it's here, yeah. I have to crop it again. Yeah, that's better. Okay, this is about functions. Here we have functions. And let's say we have to work out f from 2. So f from 2, a1, f from 2 equals to, so we take 2, in this case we take 2 from here and we put it into function f. We replace x with 2. So f from 2 would be equal to 5 times 2 minus 2 would be equal to 8. Yeah? And second one, hg, this is actually a bit harder, hg from 17. Right, hg from 17 would be equal to h from g from 17, yeah? And here we can find g from 17 by doing this. G from 17 equals 7 over 17 minus 3, yeah? Would be equal to 7 over 14 would be equal to 1 over 2, yeah? So this is equal to h from 1 over 2, yeah, it comes from here, because g from 17 equals 1 over 2, 1/2. Yeah, I think I will have to, I think actually you can just do this question, because they're both pretty similar, and they both take quite a long time to do. So 1/2, h from 1/2 is equal to h from 1/2. So we find h and we put 1/2 in h instead of x. And notice that there's 2x. There's x here and there's x here as well. So you have to put 1/2 there twice. So h from 1/2 equals 2 times 1/2 squared plus 7 times 1/2, like this. Yeah, this would be equal to, this would be equal to 2 times 1/4, 2 times 1/4, plus 7 times 1/2 is 3.5, plus 3.5, yeah, would be equal to 0.5 plus 3.5 would be equal to 4, yeah. This is our answer, 4. Okay, next one we have g from x. So g from x equals to x plus 3. Oh, I didn't need the brackets here. So g from x equals x plus 3. So this means that g from x is 7 over x minus 3, right? So we write 7 over x minus 3 equals 2 x plus 3, yeah? We can make it a fraction and we can do cross multiply like this. So we get 7 equals 2. Wait, just give me a second. Oh, okay. I had to change my position. Okay, so x minus 3, x plus 3 times x minus 3, like this, ladies and gentlemen. And, sorry, just had to check something, x minus 3. And so 7 equals x, so now we have to open the brackets. Now we open the brackets. Yeah, 7 equals 2 x squared. Oh, actually this is a formula, x plus 3x minus 3. It's actually, you can just write it as, remember the formula? It's like a minus b, a plus b equals to a squared minus b squared. So x plus 3x minus 3 equals to x squared minus 3 squared, like this. So 7 equals to x squared minus 9. 7 plus 9 equals to x squared. So x squared equals to 16 in this case. And it means that x is equal to plus minus square root of 16 equals to plus minus 4. This is your x, plus minus 4. X equals to plus minus 4 in this case. Okay, that's b. Actually, it doesn't even fit in one page. We have to add another page to do this question. Let me copy it again. Okay, so now we have to solve, it's actually a really long question, you see. Find f(h) from x equals 11. So you know you're working and giving your answer. So we have to find x in this case. f(h) from x equals to 11, right? f(h) from x is the same as f from h from x, right? Equals to 11, and we know that h from x equals to this, right? So we can replace it. So f from 2x squared plus 7x equals to 11, and now we have to take this and we have to replace x in f with this, yeah? So we're gonna get 5 times 2x squared plus 7x minus 2 equals to 11. You see, we replaced x here, we replaced with this thing. Yeah, we took this and replaced x with it. Now let's open the brackets. Let's open the brackets here. We get 10x squared plus 35x minus 2 equals to 11. This is actually a pretty complicated question. 10x squared plus 35x. Let's take it all to one side. I will take 11 here. Yeah, it becomes minus 11. So minus 13 in total equals to 0. Now we have to use the formula, right? X equals minus b plus minus square root of b squared minus 4ac divided by divided by 2a, like this, ladies and gentlemen. And let's do this. So this is our a, all right? This is our, wait, not x, just a number here. This is our b, don't forget about sign. And this is our c, right? So x is equal to minus b, so it's minus 35, plus minus, and then we go b squared, so 35 squared minus 4 times a, which is 10, times c, which is minus 13, divided by 2 times 10. You know what, if you have a calculator, I would recommend you to just type this in calculator like this, so that you wouldn't make any mistakes on the halfway. So you just type it like this, minus 35, right, plus minus, so you start with plus, okay, so you just type plus, and you have square root 35 squared minus 4 times 10 times, don't forget the brackets here, minus 13, like this, yeah, and then divided by 2 times 10, like this. You see, so you just type this whole thing, you get your answer, 0.33. Let's write it. So x equals to 0.30. We can actually kind of, I think they say to 2 decimal places, right? They say write your answer correct to 2 decimal places. You see, in 3c. Yeah, so you write x equals 0.34. And now you see what we can do is we can replace plus with a minus, and we would get x equal to minus 3.84. This is our x here. Again, just type it in calculator like this. Don't do it step by step, just type the whole thing in calculator. This way you have more probability of making mistake, because calculator is going to handle BODMAS for you. You don't have to handle the BODMAS part. Calculator will do it just fine. So just type the whole formula in the calculator. And it's going to be faster as well. Okay, next we have find. So in D we have f. We have to find f minus 1 from x. What is f from x? F from x equals 5x minus 2, yeah? So it's 3 steps, right? First step, we replace f with y, so it's equal to y equals 5x minus 2. This is first step. Second step, we swap, right? We swap x and y, so x equals 5y minus 2. And the third step, we make y the subject. X plus 2 equals 5y. Y equals 2x plus 2 over 5. So our f inverse from x equals to x plus 2 over 5. Is there anything else? Oh my god, so many questions in here. So many questions just in one question. Yeah, okay, let's do the last one. Let me copy this again. Let's do the last question. And the last question is, I have to check my battery, sorry, but it's going to be dead soon. I have to get faster, or I will have to get to the charger actually. Anyway, back to the point. G minus 1 from x, G inverse from x equals to a negative 0.5. So G inverse from x, how do you find it? G from x equals to 7x over x minus 3, right? Y equals to 7 over x minus 3. This is the first step. Second step, we swap x equals 7 y minus 3, right? Now we have to make y the subject. So y minus 3 equals 7 over x. Y equals to 7 over x plus 3. 7 over x plus 3, right? So this is our g minus 1 from x. So g inverse from x equals to 7 over x plus 3. It means that 7 over x plus 3 equals to negative 0.5, yeah? So it means that 7 over x equals to, so we can take 3 here. It's going to become negative 3 equals to negative 3.5. So x equals to 7 divided by negative 3.5. X would be equal to minus 2. Finally, I'm done with this question. X equals to minus 2. Okay, take a look again. A lot of stuff. So this is E. Here we have our C and D. And here we have A and B for this question. Okay, chapter 23, vectors and transformations. Describe fully the single transformation it maps shape A onto shape B. So you see it's like it kind of goes like this. So we can assume if it changes like this is probably a rotation. Rotation. What kind of rotation? Well, to know what kind of rotation is this, we have to connect the points. Let's try to, actually, when it comes to rotation, it's always the best to have a tracing paper with you. But we don't have tracing paper, so but we can try this. So rotation normally is like a 90 degrees rotation. We can try here. So this is the point. We can name it. Yeah, we can name it. Shape A. Let's name it A, B, C, D. And this is going to be like A1 because this is still A, right? You see? This is A. This is going to be B1, C1, and D1. Yeah? So how do we get from A1 from A to A1? You see, I determined that this is rotation, like this is obvious because you see it kind of flips this shape. It flips like this. It goes like this, then it's like this. You see it flips a little bit. So this is a rotation definitely. But what kind of rotation and where is the center? Well, this is a good question. We can try from here. So A go to A1. But you see the problem here is that the angle, you can see that the angle is not a right angle. And I can tell you, angle has to be the right angle. So let's try some other center of rotation. Let's try this. This is not a right angle. But this, look at this. Here now, this looks like a right angle. This looks like a right angle. Let's check more. Let's check D. So D goes like this. Yeah, I'm sorry. It's not very comfortable. Yeah, this is also right angle. Look at this. C, right? Another right angle. So this is our center of rotation. And I will show you what happens. So this becomes this, right? And for example, C, I'm not gonna draw all the points. Let's just draw 2 of them. C becomes C1. Yeah, so you see A becomes A1. Oops. A becomes A1 and C becomes C1. And what rotation is this? What rotation is? Rotation 90 degrees. It's a 90 degrees rotation. Rotation 90 degrees. It's anti-clockwise, so this is clockwise and this is anti-clockwise, right? Rotation 90 degrees, anti-clockwise. About we have to find the center. So the center point in this case is this point, and this point is called 0, 2. Rotation about point 0, 2. Like this. Okay, second shape A onto shape C. So this looks like a reflection, yeah? Shape A onto shape C, definitely a reflection in this case. And what is left is to find the reflection line. So we can try, maybe this is a reflection line. So the thing is the distance from reflection line to the points of original shape and reflected shape should be the same. Okay, let me show you what I mean by that. So this is our B2, A2, B2, A2, B2. This is C2, C3, like this. Yeah, and so the thing is, the distance. So basically what we can do is we can draw a line. We can draw a line between those 2 points, B and B2 for example, and we can find where is the middle of this line. So the middle of this line is here. All right. So basically we can just draw a perpendicular bisector of the distance between like B and B2. So it's going to be here. This is exactly the half. You see why it's half? We have 1, 2, 3 points on this side, and 3 cages, 3 steps on this side. 1, 2, 3 steps on this side. We have 1, 2, 3 steps on this side. Yeah. So the reflection line is what is it? It's like y equals to 1, right? Y equals 1. X can be anything, whatever, but y is always 1. So it's reflection. It's a reflection at line y equals 1. Shape A onto shape D. Okay, this is the transformation that you haven't learned yet, but this is called enlargement. I will show you how to do it as well. This is called enlargement. And so for this transformation, and we see that this A, B, C, D, and D, you see they have different sides. So this is only possible if we are talking about enlargement transformation. Yeah. So let's label the points again. A3, B3, this is our C3, and this is D3. And so what we have to do is we have to draw the rays between those points. So A to A3, let's draw the ray here. B to B3, draw the ray here. D to D3, like this. And then finally we go C to C3. You see all these lines, they intersect here. And so what happens here, we go, so if we're talking about normal enlargement, if we will go from the center, the projection would be like somewhere here. The projection would be somewhere here. But because you see what happens, this is a twisted enlargement. This is called enlargement with a negative scale factor, because we kind of go back to the center of enlargement and then we go in the opposite direction. So this enlargement is a negative scale factor enlargement. And you see what happens to the shape. For example, AB, it was 2 cages long, but now AB is just 1 cage long. So this is enlargement, which is in fact kind of like an ensmallment, I would say, because it becomes smaller. It became 2 times smaller. So this is called enlargement. Enlargement with, so this is maybe, no, this is not a new word for you for sure. Enlargement with scale factor of -1/2 and center at 0, 0. Okay. And last one on the grid, draw the image of the shape A after translation by a vector 2, -3. So 2 - 3, it means 2 steps right, 2 steps right, 3 steps down. So every point of ABCD is going to move 2 steps right and 3 steps down. So B goes, 2 steps right and then 3 steps down. This is our new B. Let's call it B4. Yeah. C goes 2 steps right and 3 steps down. So this is new C. This is C. This is C4. Yeah. A goes 2 steps right and 3 steps down. So this is new A. And I think by this point you can already see what's happening. So we can just draw the shape already. Like this, like this, like this, and then like this. This is our translated shape. Let's color it. Let's color it. Whoops, too big. Let's color it like this, yeah? This is our translated shape. Okay, that's it for vectors and transformations, and that's it for our review. At any time, you can go back in this video. I think I will add subtitles to this video, so you can rewind, and this is all the content we will be having on our exam.